learning outcomes. After studying this module, you will be able to, number 1, know about the table and graphs. Number 2, various types of tables and graphs and their use. Number 3, forensic applications of tables and graphs. Introduction. The very first step in analysis of data is to classify and tabulate the data. After classification, the data is presented in the form of tables and graphs. The data can be represented in a concise manner using graphs and tables, but it is necessary to explain the data clearly. Classification and tabulation of data is not always interesting. Too many figures can be confusing sometimes and may fail to convey the meaning effectively or message effectively. Another good and interesting way to represent the data is by using graphs and diagrams. There are various ways in which a data can be represented pictorially using graphs, diagrams, maps, etc. Choosing the best way of representing the data is a difficult task and requires a great deal of artistic talent.
So let us begin with tabulation of data. One of the easiest and best ways to summarize data and present it in an efficient and meaningful way is statistical table. A table is a methodical representation of statistical data in columns and rows. Rows are the horizontal arrangements, whereas columns are the vertical arrangements. The basic objective of constructing a table is to simplify the presentation of data and to ease comparisons. This simplification results in precise and organized presentation of data, which enables the reader to quickly locate desired information. Further, comparison is facilitated to bring related items of information close together. So now, the question that must come to your mind is how to construct a table. The difference between classification and tabulation of data. Yes, classification and tabulation are not two different processes. They go together, where classification is the first step for tabulation. Classification is necessary to put the data in a tabular form. According to the various similar and different characteristics of the data can be classified and tabulated. Only after meaningful classification, the data can be represented under rows and columns. Now, before further proceeding, let us see what are the advantages of data tabulation. Tabulation allows arrangement of large amount of data in minimum space. And critically, one can say that tabulation simplifies complex data, facilitates comparison, gives identity to the data, and reveals patterns. Let us take each one of them in detail now. Tabulation simplifies the complex data. Tabulation of data leads to exclusion of all repeated and unnecessary data. Systematic representation of data in rows and columns gives reader a clear idea of what table presents. This further deletes duplicacy of data and saves time and space. Tabulation also facilitates comparison. Tabulation of data helps in comparison. It gives the relationship between various parts of the data, which can be easily studied via tables. Also, tabulation gives identity to the data via title, number, etc., which helps to identify the source reference in the interpretation of the data. And finally, tabulation also reveals patterns which cannot be revealed within a figure through narrative data but can be easily interpreted using tables. Now, let us see how the tables can be partitioned, or let us look at the parts of a table. The number of parts of a table depend on types of data to be presented and variation from case to case. The basic parts used in a table are table number. Table number refers to numbering of each table. Numbering of each table should be done. The number can be given in the center, at the top above, or inside the title, or at the bottom or top of the table. Title of the table. A suitable title should be given to every table, which gives description of the contents of table. It should provide all relevant answers about what precisely the data in the table represents. It should be self-explanatory, brief and clear. Short titles can be read fast and easily as compared to long titles, but it is sometimes necessary to put up long titles for the sake of clarity. Font of the title should be prominent on the table. Caption. Caption refers to column headings. It depicts whatever the column represents. More than one column heading may or may not be present. These captions should be placed in the center of the column, respectively, and should be precise and clear. Ideally, these captions should be of small font size as compared with the main part of the table. Stub. Now, this is something different from that of a caption. This refers to the designations of the rows and row headings. These are present towards the left and perform the same function for the horizontal rows of numbers in the table. They are usually wide as compared to column headings, but should be kept as narrow as possible. Body. This is the most important part of the table. Data presented in the body is arranged according to the classification of the captions and stubs. Head note. It is a brief and precise explanatory statement applying to all or a major part of the material in the table, and ideally it should be placed below the point centered and enclosed in brackets. Headnotes are used for explanation of various facts which are not mentioned in the data or in captions or in stubs. Footnote. Any fact or material which is not clear from the title, captions or stubs is explained in footnotes. These are generally placed directly below the table if required. Now one can see the format of a table and all the relevant parts that we have discussed in this figure. Now let us look at the general rules of tabulation. It is very difficult to lay down any strict rules for tabulating data because much depends upon the given data and requirements of the survey. Construction of a perfect and a meaningful table is an art. However, one can have following considerations in mind while formation of tables. Tables should be constructed according to the size of the paper or layout, usually with more rows than columns. Alteration of original design is sometimes necessary to give a suitable layout. Changing rows to columns or the other way round are the basic alterations. Appropriate space for reference or any other data should be included in the table. Arrangement of captions and stubs should be done in a systematic order. This systematic arrangement makes the table simplified and easier to read and understand. One can arrange the captions and stubs in the following manner: alphabetical manner, chronological manner, geographical manner, conventional or in some customary order, or according to the size. The points of measurements or reference should be clearly defined in the table. Rounded figures should be used to avoid unnecessary details. If emphasis have to be given to a particular figure or data, it should be in distinctive type or in a box. Overloading of tables should be avoided. A column entitled miscellaneous should be added for data which does not fit in the classification done. Logical arrangement of tables should be done and every item should be relatively placed. Computation of percentage and ratios should be done and shown. Where standard classifications have been prepared, it is usually desirable to employ them as they are superior to otherwise constructed individual classifications. Avoid abbreviations, especially in headings and titles. Be explicit and ditto marks should be avoided. Now, types of tables. Tables can be broadly classified into two categories. Number 1, simple and complex tables, and number 2, general purpose and special purpose tables. Simple and complex tables. According to the number of characteristics, distinction between simple and complex tables can be made. In a simple table, one characteristic is shown, so it is known as a one-way table, whereas complex table is known as a two-way table or double tabulation as two or more characteristics are shown. These tables are preferred as they represent overall information and facilitate proper consideration of all the related facts. The tables in which three characteristics are shown are referred to as treble tabulation. Let us look at the examples now. For one-way or single table, there is only one characteristic shown, that is the number of employees in a company according to age group. Now, the other example is for a double table where two characteristics are shown and is formed when either the stub or caption is divided into two coordinate parts. Over here, one can see that the number of employees of a company in different age groups according to sex are classified. So we have the employees classified or categorized into different age groups further as males and females, general or special purpose tables. These are also known as reference tables or repository tables or derivative tables, which provide information for general use or reference. They are not made for any special discussion. They contain detailed information. In other words, they are the storehouse of information which are arranged for easy reference. They are referred to as summary tables as they provide information for a particular discussion. When they are attached to a report, they are found in the body of the text, as one can see from the example, where the number of males and females, literate and illiterate, are classified into different age groups. With this, now let us look at the other data analysis technique, which is representation by graphs. A large variety of graphs are used commonly. Graphs can be classified into the following categories. Number 1, graphs of time series and graphs of frequency distribution. Construction of charts and graphs is an art which can be acquired through practice. There are a number of rules, adoption of which leads to the effectiveness of graphs. We will look into the rules for constructing such a graph. Following points should be kept in mind while constructing a line graph. Take the time on x-axis and the variable on y-axis. Begin y-axis with 0 and select a suitable scale so that the entire data is accommodated in the space available. Corresponding to the time factor, plot the value of the variable and the various points by straight lines. Join the various points with straight lines and not curves. More than one graph should be distinguished by the use of dotted lines, thick or thin lines, or so on. Appropriate titles should be given to every graph, and lettering on the graph should be done horizontally only. Now with this, let us look at the graphs of one variable. In case of one variable, x-axis represent time and y-axis the value of variable. Various points are plotted accordingly and joined by straight lines. Variations in the variable is indicated by the fluctuation of this line, as can be seen in this graph. Now the other category is graph of two or more variables. Two or more variables can be represented on the same graph in case of same units of measurement. This helps in comparison of data. But in case of large number of variables, this type of graph becomes quite confusing to understand. To distinguish between the variables and for the sake of clarity of data, broken, dotted or differently colored lines are used, as can be seen in the figure. Now, another category under this section of graphs is a band graph. It is a type of line graph which depicts the total for successive time periods broken up into subtotals for each of the component parts of the total. In short, it is a graph which shows how and in what proportion each item comprising the aggregate are distributed. Several component parts are plotted one over the other, and the gaps between the successive lines are filled by different shades, colors, etc. to give appearance of a series of bands, as one can see in the graph. Now, graphs of frequency distribution. These types of graphs can be presented in the following ways: histogram, frequency polygon, smooth frequency curve, ogives or cumulative frequency curves. Now let us begin with histogram. It is one of the most popular and commonly used graphs. It is a set of vertical bars whose areas are proportional to the frequencies represented. X-axis represent variables and frequencies depending on it are represented on y-axis. Each class is represented by a distance on the scale which is proportional to its class interval. If the class intervals are uniform, the distance for each rectangle formed on x-axis will be the same. They vary if they are different. The y-axis represents the frequencies of each class, which constitutes the height of its rectangle. It is important to distinguish bar diagrams from histograms. The main difference between them is that a bar diagram is one-dimensional, in which only length of the bar is important, whereas histogram is two-dimensional, in which both length and width are important. Construction of a histogram is not possible with open-end classes. If the distribution has unequal class intervals and suitable adjustments in frequencies are not made, then a histogram can be quite misleading. Now, the second category is frequency polygon. It is a graph of frequency distribution and has more than 4 sides. It proves to be useful for comparison of 2 or more frequency distributions. Further, frequency polygon can be constructed in 2 ways. Number 1, we may draw a histogram of the given data and join by straight lines the midpoints of the upper horizontal side of each rectangle with the adjacent ones, as we can see in the figure. Now, such a diagram or a figure is referred to as frequency polygon. An alternate method for construction of frequency polygon is to take the midpoints of different class intervals and then plotting the frequency corresponding to each point. Joining these points by straight lines gives a figure as obtained in the previous method, as can be seen from the graph. Let us look at the advantages of frequency polygon over histograms. To make certain comparisons possible, the frequency polygon of several distributions may be plotted on the same axis, whereas in histogram, a separate graph is required for each distribution. Frequency polygon is comparatively simple, where the data pattern is clearly represented. With increase in the number of classes and observations, the polygon becomes smoother and curve-like. Now, next category is smooth frequency curve. Various points of the polygon needs to be considered while constructing a smooth frequency curve. It is drawn freehand such that the included area under the curve is more or less the same as that of the polygon. Its main objective is to eliminate accidental variations that might be present in the data as far as possible. The 2 steps for drawing a smooth frequency curve are draw the polygon and smooth the polygon. While smoothing of curve, following points should be taken into consideration. Only frequency distributions based on samples should be smoothed. Only continuous series should be made smooth. The total area under the curve should be equal to the area under the original histogram or polygon. With this, we come to the next category of graphs, that is Ogives or cumulative frequency curves. Cumulative frequencies are the added frequencies which are listed in a table called Cumulative Frequency Table. The curve obtained by plotting the cumulative frequencies is called Cumulative Frequency Curve or an ogive. 2 ways for construction of ogives are: number 1, less than method, where we start with upper limits of classes and then keep on adding the frequencies to obtain a rising curve, as can be seen in the figure. And the second is more than method, where we start with lower limits and keep on subtracting the frequency of each class to obtain a declining curve, as can be seen. Now, these ogives are used to find and show the number or proportion of cases above or below the given value. These are utilized for comparison of 2 or more frequency distributions and for graphical determination of certain values such as medians and so on. Pie diagrams. Circle diagrams are alternative to square diagrams and are used for the same purpose, which is for diagrammatic presentation of the values differing widely in their magnitude. The area of the circle which represents the given values is given by pi r square, where pi is equal to 22 by 7, that is 3.14, and r refers to the radius of the circle. Just as subdivided and percentage bars or rectangles are used to represent the total magnitude and its various components, the circle may be divided into various sections or segments which, in sectors, represent certain proportion or percentage of the various component parts to the total. Such a subdivided circle diagram is known as angular or pie diagram or chart. This is named as pie diagram or chart because the various segments resemble slices cut from a pie. In order to construct a pie diagram, one must learn the steps involved in the construction of pie diagram. Express each of the component values as a percentage of the respective total. Since the angle at the center of the circle is 360 degree, the total magnitude of various components is taken to be equal to 360 degree, and each component part is expressed proportionately in degrees. Draw a circle of appropriate radius using an appropriate scale depending on the space available. If only one category or characteristic is to be used, the circle may be drawn of any radius. Having drawn the circle, draw any radius. Now with this radius as the baseline, draw an angle at the center equal to the degree represented by the first component. From this second line as base, now draw another angle at the center equal to the degree represented by the second component to give the sector representing the proportion of the second component. Proceeding similarly, all the sectors representing different component parts can be constructed. Different sectors representing various component parts should be distinguished from one another by using different shades, dottings, colors, etc., or giving them explanatory labels either inside the sector or just outside the circle with proper identification. The degree of any component part can be calculated as component value upon total value into 360 degree. Now let us look at the pie diagram representing percentages of blood groups for a group of 200 people. Over here we can see that 16% corresponds to blood type A, 25% corresponds to blood type B, 40% corresponds to blood type O, and 19% corresponds to blood type AB. Using this data, one can calculate the number of people corresponding to blood type AB, blood type O, blood type A, and blood type B. Let us look at the applications of tables, graphs, and diagrams in forensic science. Tables and graphs are widely used in forensic science to tabulate the various evidences found and their findings. In case of estimation from bones, the measurements are tabulated for easy calculation and observation. Graphs are also plotted while determining time since death and to estimate the timings of wounds. In forensic psychology, techniques like polygraph involves plotting of graph to analyze and interpret the results. Tables and graphs are used in various other branches of forensic science as well. The table, so given over here, refers to the data collected about victims in case of a mass disaster. This tabulated data helps in identification of victims.
Summary. The very first step in analysis of data is to classify and tabulate the data. A table is a methodological preparation of statistical data in columns and rows. Arrangement of captions and stubs should be done in a systematic order. According to the number of characteristics, distinction between simple and complex tables can be made. In a simple table, one characteristic is shown, so it is known as one-way table, whereas complex table is known as two-way table or double tabulation, as two or more characteristics are shown. General or special purpose tables are storehouse of information which are arranged for easy reference. Large variety of graphs are used commonly. Graphs are classified under following categories: graphs of time series and graphs of frequency distribution. These types of graphs can be presented in the following ways: histogram, frequency polygon, smooth frequency curve, and ogives or cumulative frequency curves.